Hi, in this video we will continue studying possible solutions for the programming exercises of chapter 3 that are needed for unit 4. So in this programming exercise 3.4, the hardest part to understand from the problem is the formula that is being specified here. I think the easiest part is when it says that what the user needs to give us. So it says the height from the ball, and is indicating here the what we expected, which in this case will be my input, which is these three variables: height, bounciness, and bounces. Now we have to compute the output is the total distance, so we had to initialize a variable that is distance with 0. Now this will be a loop in that depends on the number of bounces, right? And then this is how the formula and the distance is gonna be changed. And is the distance is gonna be whatever was the distance before plus the height, and then the height is gonna be times the bounciness, and then the distance again times the height. So this is just the way that, and I think this was the hardest part to understand the formula. For exercise 3.5, again, you had to do a good reading to understand the formula, and the easy part is again understanding what's the input, what is it that they want. So in this case, the input for this exercise are these four variables as listed in here. So this is really easy to understand because they're listing here as 1, 2, 3, and 4. Now they will explain how is that they do the calculation for the number of cycles, and we just need to be sure that we understand how the cycles are being computed as the uh, formula given over here. The last section in the program will be the actual calculation of the population uh, depending on the number of cycles. So there will be here multiple iterations. So one easy way of doing this is using a for loop. And then once we go and iterate over all the number of cycles and we change that number, then we can print the result. So look at the print statement that we have here after the result, and don't forget to in the indentation. So this is inside the for loop. Okay, again, I think the hardest part is still understanding the formula. So in this case, we want to compute this, and you need to spend time understanding this. This is pi divided by 4, right? Pi over 4. And we're going to be doing this for a number of iterations. So iteration will be how many terms we're going to have here. So an example given here is 1, 2, 3, 4 terms. And you see this is the first one is a whole number, so it's 1 actually divided by 1. But look at what is happening in the denominator. So it's 3, and then from 3 is going to 5, and then 7. So it's changing that by 2's. So then, and the signs is going from negative to positive, positive, negative, positive. So the next one here, we can predict that it's going to be 1 over 9, and then negative 1 over 11, right? So then we have to ask the number of iterations, pi over 4. We have to initialize that to 0. And then we're going to talk about numerator and denominator because that's what we're going to do. And then we're just going to have to do an addition. Then we need to determine how is that we will actually, this is just a summation. So in this case, we're going to be counting, or we will be repeating this by the number of iterations that we have. So and in this case, pi over 4, it starts with numerator and denominator. So you see that the first one is 1 divided by 1. So that's the first element, right? Now look at the numerator. We changing the sign. The numerator is always 1. So we're going to change the signs to positive, negative, negative, positive. So it was positive. Now it's going to be negative. And the denominator, we're going to change that by adding 2. And we're repeating this the number of times given on iterations. So once we have that, we can actually display the answer, which is uh, the approximation, and then they want us to compare the results with the actual pi and the estimated pi. For exercise 3.7, again, what I see that may be an issue is understanding the question. I mean, it's, in this case, they they're assuming that a teacher, for example, in a given school district, will get increments of 2% per year for the next 10 years. And then what they want us, they clearly say, we want the starting salary, what will be the annual percentage increase, assuming that that will be fixed. In the example here, they said, let's suppose that somebody gets 30,000 and then for 10 years they're going to get 2%. But the program should work for any school district. For this district, it's 30,000 year one, and then after each year is 2%, 2%, 2%. So here they want us to say what will be the initial salary for a teacher with 0 years of experience, I guess, and then what will be the annual percentage increase that you can expect and for how many years you want to display that. And then they wanted to show it in this nice way like a table. So they want us to practice a loop and formatting. So the first part of the program is asking the inputs, which is the starting salary, the increase in years. For the next section, we will then just given the increments. So in this case, this is the header of the table, and then the multiplier is if, for example, there is 3%, the increment is going to be 3 divided by 100, which is going to be 0.3 plus 1. So that multiplier is the value that you're going to use to get the raise. So this is the next salary. So this is the variable that we're going to use for the iterations. So here is the starting salary. So the starting salary is going to be fixed, but initially that's the first year. So here is going to be year for a number of years, right? From year one up to whatever number of years they gave in the input. So this is the part for the formatting. So it looks like a table. So here 2 digits and 12, up to 12 digits here. I mean all together including decimals. So they just to give the width of the table, and then is display the year and the next salary, and the next salary is whatever is the salary before times the multiplier. So each year you multiply the salary by 1 point, if that was a 3, 1.03.